Okay, so we're back for the second finishing part of the video. And I'm sorry at the end there. I was fixing my derivative notation because I had gotten lazy as I was speaking and did not include the d dx showing that I was taking the derivative on the right side. So I went ahead and fixed that in this new video and remembered to insert it before my inverse tangent in this example. So again, I want to take the derivative of inverse tangent of the natural log of x. So notice my inside function, my outside function. So it's a chain rule. The derivative of the outside, 1 over 1 plus the function squared times the derivative of the natural log of x, which is 1 over x. So I'm going to simplify this a little bit, and I'm going to write the 1 over x in front, and then put 1 plus, I can leave these parentheses, natural log of x squared, or I could rewrite it like that. What I can't do is this. That is not equivalent to the quantity natural log of x squared, because this is squaring the x, and this is squaring the natural log of x. Kind of like the same thing as our trig functions. This does not equal that. So be careful with your parentheses, and yes, be careful with your parentheses. So I think just for example's sake, I'll do one more. So let's say y equals 5x times inverse cosine of 1 plus x squared. So now, if I want the derivative, I know I need product rule. First function, second function. The derivative of the first times the second plus the derivative of inverse cosine is -1 over the square root of 1 minus the function squared times, this is our chain rule, the derivative of that function times my first function, which is the rest of the product rule. So again, the derivative of the first function, 5, times the second, plus the derivative of the second function, which is -1, over the square root of 1 minus the function squared, times the derivative of that inside function, times the first function. So just to clean that up a little bit, and again, if this were to occur on a free response question, oh, hi. I would not simplify it, because if you simplify it and you make an error, you lose a point for the answer being wrong. And yes, this would simplify. If you FOIL this, distribute the negative in, things will cancel, the ones will cancel. But I'm just not going to. That doesn't mean I never will. But I'm going to leave it like that. Perfectly acceptable. Okay? Now, if this were a multiple choice question, they may have FOILed this out and simplified the radical a little bit, and they may have factored out a 5. Probably not, but they may have. So I just wanted to do one that was a little bit harder so you could see how the inverse derivatives can work with the rest of your derivative rules. And that will conclude our examples for the derivatives of inverse trig. So again, you can go back and look at the videos, pause them when you need to, email me if you have any questions, and from your summer assignment, actually let me just pull it up, I have it down here. this video will help you with numbers 9, 10, 11, and 12. So I mainly put 4 inverse trig derivatives in there. 1 for you guys, and 2 so that the kids who already had AB this year will review it, along with, if you notice, there's a product rule in here. There's some e's. There's some natural logs somewhere around, maybe not in this one. But so this will help you with 9, 10, 11, and 12 from the summer assignment. So if you want to, you can do those 4 problems now, since this topic is fresh in your mind. And you can email me if you have any questions. All right? Thank you so much. Bye.